Now we're going to get in some practice with doing orbital notations and electron configurations. And what I'd like to do is, on my website there's a copy of this periodic table, and it would be real helpful if you would print that out. And you need 4 different colors of colored pencils or highlighters or crayons, something to mark up this periodic table with. What we're going to look at is how the layout of the periodic table corresponds to the quantum model. So we're going to, let's see, get our highlighters going. And so first I want you to highlight this area of group 1 and group 2, and we're also going to include helium in that, okay? And we're going to call this the S block, okay? And then we'll get a new color, let's say blue, and highlight that. Oops, no. It's on highlighter, and we want the ink color to be blue. Okay, and so then we're going to highlight this area here. Well, and actually we can include this piece down here as well. Okay, this copy doesn't have any elements on it, but a newer one would. And we're going to call that the P block. Okay, our center here, we're going to highlight that, and there, okay, and that is going to be the D block. And then the remainder, let's do orange here. Okay, and that is, if you haven't already guessed, the F block. Okay, and we're going to number the rows 2, 3, 5, 6, 7. Okay, and for the S and the P block, all right, the principal quantum number corresponds to the row number. Okay. Then for the D block, the principal quantum number is going to be the row number -1. So here in our D block, this is going to be 3D, 4D, 5D, 6D. Okay? And then for the F block, principal quantum number is equal to the row number -2. All right, and so this would be 4F. Remember, it picks up right here. Okay, that break where we drop down and pick up that's right there. And so it's in row 6. So the principal quantum number for this set of F orbitals would be 4. And then the one below it is 5F. Okay? And so the way to use this, again, remember I said you don't have to memorize the order with which they fill, because you can just follow the periodic table. Okay? We have 2 blocks, 2 elements that represents 2 electrons. So every 2 blocks represents an orbital. Okay, so we have, this is a 1s electron here, and then the helium is a 1s. The lithium is a 2s, and a 2s, and then we get over here 2p. All of these are 2p's. Okay, that's the energy level, and remember this is actually 3 orbitals. There's 1, 2, and 3. Okay, so the width of the block tells you how many electrons can be in that sublevel. So the 2p sublevel has 6 electrons in it, or 3 orbitals. Okay, then here's 3s, 3s, 3p, all the way through here. I'm just writing all this out. Then here, remember how the 4s and the 3d overlap? So that right there it is, 4s, and then now we get into the 3ds, and so forth. Okay, so let's take a look at some examples of that. Let's do some orbital notations, and then let's do some electron configurations. Here's a very nice looking one that we didn't mark up, but it also shows you the same thing. Okay, so orbital notation. So let's just take a look. Let's do a couple. I think we did hydrogen. So let's do, there's helium. All right, helium has 1, 2 electrons. They're both in the 1s. So I would have the orbital with 2 electrons in it. Okay, 2 arrows, one up, one down to represent opposite spins. Let's look at what nitrogen would look like. Again, we always start here, go across, drop down to the next row, and we keep going until we get to the element we want. And this time, we're wanting nitrogen. So we go through the 1s, then drop down, we go to the 2s. Okay, and now we go to the 2p. And here, the thing to remember, when I get to a sublevel that has more than one orbital in it, I'm going to draw all of the orbitals, even if I'm not going to actually put electrons in them. Okay, so for instance, if I was doing boron instead of nitrogen, I would still draw all 3 of the 2p orbitals. Okay, relating back to our Hogg-Hilton, we cannot, if a sublevel represents a suite of rooms in the Hogg-Hilton, we can't put any Hoggs in an unfinished suite. We have to have all 3 of the rooms. If it's a 2p sublevel, all 3 orbitals have to be there. We're going to draw those. Then we're going to put the electrons in them. So here I have 3. Nitrogen represents 3 in the 2p sublevel. Okay. All right, let's do one that's a little bit bigger. Let's look at, how about nickel, right there. Okay, so for nickel, again, it always starts the same. 1s, 2s, 2p, and I'm going all the way through that. Okay, then we're dropped down to the 3s, and then 3p, and that one's going to be also completely full. Remember Hund's rule, we go one at a time, then fill them. Then there's the 4s, and then the 3d. Again, I'm going to put all 5 of those orbitals in. For these, I'm just going to do 3d1, 3d2, 3d3, 3d4, 3d5. Okay, and then nickel, if we're going to count 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. So we put them in one at a time, and then 3 of them will have to double up. So there is our orbital notation for nickel.